Hi class, this is for grade 11th and 12 college. Today we're going to learn how to balance redox equations. So this occurs on page 853 of your text. Well, it starts around page, the actual instructions on how to balance equation occurs on page 851, which you don't have because you don't have access to the text. I don't know if you have access to Brown et al. 10th edition Chemistry, the Central Science. It says AP edition on it. Cover is white, in case you forget. This is what it looks like. So if you want to see it, well, buying it online or downloading it online, I know the text companies are allowing that to happen for the time being. But I've heard of a few things going on. Anyway, you don't really need the textbook. I can give you all the things you need. When you balance when you're balancing redox reactions, you want to separate the reaction into half reactions, then balance the elements, but not H and O, then balance O with H2O, H with H plus, and the charges with electrons. Use integers to balance the half reactions, then add them together, and finally write the net equation. So I'll do an example for you to show you how that works. This is just part of the main lesson. I actually want you to watch parts 4, 5, and 6 of my electrochemistry playlist, because that's a full class with all the explanations that you need. Parts 4, 5, and 6 of my electrochemistry playlist. And it'll show you all the stuff that this lesson will briefly touch upon. Although don't ignore this lesson because it also gives you the basics. All right, so half reactions. Let's take this redox reaction in which copper solid turns into ions of copper, and the nitrate anion turns into nitrogen dioxide, which is a gas that comes out of solution. So turn it into half reactions. Copper, actually you can dispense with writing the states because that's just going to slow you down. Copper solid turning into copper ions. And to do that, there's no hydrogens to worry about, there's no oxygen, so the only thing you have to worry about is the electrons. So you've oxidized the copper, so you're going to put 2 electrons on that side to balance the charge. You see there's a +2 over here, no charges over here, so you add 2 electrons, and the charge here will equal the charge there. Total charge here is 0, total charge here is also 0 now. Let's do the second half reaction. The nitrate anion is turning into nitrogen dioxide. On this one, you have 3 oxygens on the left, 2 oxygens on the right, so you're going to add a water, and that provides you the missing oxygen. By adding a water, you create a surplus of 2 hydrogens, so you're going to add 2 hydrogens on the left as well. And now you can balance the charges. There's no charges on this side, and on this side the total charges is -1 plus 2 gives you +1, so adding 1 electron is going to balance that off. Now what you do is multiply this whole reaction by 2. Why would I do that? Because I want the same number of electrons in both reactions. You see, this is an oxidation and ends up with 2 electrons being produced, whereas this is a reduction, but it only takes 1 electron for it to take place. So this reaction has to run twice before you get enough electrons to run this reaction once. So that's why we're multiplying the reaction by 2. Then we add the 2 reactions together. I'm just going to write everything down below the line. So it'll be 2 electrons plus 2 nitrates plus 4 hydrogens plus 2 coppers turn into cupric plus 2 electrons plus 2 nitrogen dioxides plus 2 waters. Now we're just going to cancel everything that we can cancel. The 2 electrons cancel and nothing else cancels, so now we'll just write the net reaction. So 2 nitrates aqueous, this is when we rewrite the states again, plus 4 hydrogens aqueous plus 2 copper solid yields how did I suddenly acquire 2 coppers? No. that's gone. And copper 2 plus aqueous plus 2 why is this plus now? You gotta be extra careful what you do, or you end up riddled with airs. That's a gas, and 2H2O liquid. That's your net equation. Let's see if I got it right. Copper solid, yes. 4H plus is aqueous, yes. 2 nitrates, aqueous, yes. Cu2 plus aqueous. 2 nitrogen dioxide gas plus 2H2O liquid. That's the correct answer. Let's try another one. Part B. I'm wondering if I have enough space on the fridge. Maybe I'll lower the phone a bit and use all the bottom of the fridge. So the equation here is manganese 2 plus sodium, I think it's called bismate, NaBiO3 plus Bi3 plus aqueous plus permanganate at the end. Okay, so this is what you start off with. Am I blocking it? No. Begin by separating the half reactions. Maybe because I'm left-handed, I should sit on the other side. Let's see if that works better. So we'll start off by separating the half reactions. Manganese ion is turning into permanganate, and NaBiO3, which is a solid, is turning into Bi3 plus. The manganate has 4 oxygens on the right, so we're going to have to put 4 waters to balance all those oxygens, which creates a surplus of 8 hydrogens on the left, so we're going to have to add 8 hydrogens on the right to balance it off. And then let's look at the charges on the first half reaction. The total charge on this side of the reaction is +7. The total charge on this side of the reaction is +2. There's no charge in the water, it's only the +2 over here. So +7 on the right, +2 on the left. So it's a surplus of 5 positive charges on the right. So we're going to add 5 electrons on the right to counterbalance it. Now the charge on the left is the same as the charge on the right. On the second half reaction, you're going to add a sodium there to balance the things that are not either oxygen or hydrogen. Then you have 3 oxygens on the left, so you're going to balance that off by adding 3 water molecules. The 3 water molecules create an imbalance of 6 hydrogens. So you're going to add 6 hydrogens on the left to balance that off. Now you're going to look at the charges. There's 6 plus charges on the left and 3 plus charges on, oops, there's a plus charge over here. So there's 4 plus charges on the right. So let me check my notes here before I lead you down the garden path. There we go. Yeah. So the way we're going to balance that off is by putting 2 electrons on the left. Okay, let me explain that. You got 6 pluses over here and 4 pluses over there. So there's an extra 2 plus charges on the left. So that you're going to balance that off by adding 2 electrons on the left. Now, one half reaction has 5 electrons and the other half reaction has 2 electrons. So how are you going to balance those 2 half reactions? Multiply this one by 5 and multiply this one by 2. And by doing that, you're going to get you're going to get a the following. It's going to get messy. You're going to get 2 permanganates, 2 times the 4H2O gives you 8H2O. 5 times 2 electrons gives you 10 electrons. 5 times 6 hydrogens gives you 30 hydrogens. 5 times NaBO, O3. Then you're going to have 2 times the permanganate plus 16 hydrogens plus 10 electrons plus 5 bismuth, 3 plus 5 sodiums plus 6 H2O. No, sorry, 15 H2O, because 5 times 3. Now, I know the right side of the equation is all scrunched up. 10 electrons will cancel the 10 electrons. 30 hydrogens will cancel with the 15 hydrogens to give you, why do I have 16 hydrogens over here? Three, 5, 30. Sorry, it's 2 times 8 gives you 16. Where's the 16 hydrogens? Yeah, I was canceling water. Sorry about that. Okay, this 30 hydrogens cancels with 16 hydrogens to give you 14 hydrogens left over. So I'll write that over here. The 8 H2O cancels with the 15 H2O to give you 7 H2O on this side. And I think now we're ready to write our net equation, which you can still see, I gather. Okay, so we have at the end 2 Mn2 plus aqueous plus 14 hydrogens aqueous plus 5 NaBiO3 solid, giving you 2 permanganates aqueous plus 5 bismuth 3 plus. You know what, when you name ions, the higher charged ion is given the ic ending and the lower charged ion is given an us ending. I don't know if bismuth has another charge besides plus 3, but how would you call that? Bismuth? Anyway, I prefer to say the number on this one. So bismuth 3 plus 5 sodiums. These are both AQ. It's getting really messy. And then the 7 waters. Yeah. And there's your net equation. I apologize for the messiness, but this is the best I can do with a fridge as a writing surface. Now, sometimes, okay, both of these have been balanced using acidic solution. Sometimes, though, you will be asked to balance an equation using basic solution. So when that happens, you balance the equation the same way as you normally do, but then what you do is you add hydroxide to the hydrogens to create water, conceptually, of course, and then you'll have it balanced in hydroxide. So I'll do one example that way, but now I have to erase, and this is the fun part. Usually it helps to start with water and then to use some alcohol to clean up the mess it makes. Just bear with me. The next thing I'm going to do is page 855, practice exercise, and you don't have the book, so that doesn't help anyway. Okay. Now we're going to use our alcohol to clean it up. I will definitely have the cleanest fridge in Toronto when I finish this teaching. Okay, good enough. Now we're going to balance using basic solution. So this is from practice example on page 855. A, it shows nitrite anion aqueous reacting with solid aluminum to yield ammonia. Uh-oh, it's still wet here. Ammonia plus aluminum hydroxide aqueous. Let's separate it into the two half reactions. So we start off with nitrite turning into ammonia. That's going to take two waters to balance out the oxygens. That creates now an imbalance of 3 plus 4, 7 hydrogens. So we're going to have to add 7 hydrogens to the left. And to balance the charges, we have 0 charge on the right side, plus 6 on the left, so we're going to add 6 electrons to bring both sides down to 0. First half reaction is balanced. Second half reaction is taking aluminum and turning it into a hydroxide of aluminum with a charge on it. So that has 4 oxygens on the right, so we're going to add 4 waters on the left. And now we have 8 hydrogens on the left and 4 hydrogens on the right. So we're going to add 4 hydrogens this side to balance it out. Now let's balance the charges. We got a negative 1 over here and a plus 4, so that total on this side is plus 3. How do we bring it down to both of them having the same 0 charge? Add negative 3. By the way, we're not always shooting for a 0 charge. It could happen that one side has a minus 2 and the other side has a plus 5. What you're going to do is make it so that you add electrons to the more positive side so that the charge on the more positive side ends up equaling the charge on the more negative side, or less positive side as it were. So now that we've balanced the half reactions, we're going to multiply the second one by 2, because see, the second one only produces 3 electrons, whereas the first one consumes 6 electrons. So this half reaction has to happen twice before this half reaction can happen once. So we're going to add the results over here now. Now is where it gets messy again. So 6 electrons plus nitrite anion plus 7 hydrogens plus 8, because 2 times, right? 8 H2O plus 2 Al gives you ammonia NH3, 2 H2O, 2 AlOH4 minus 1 plus 8H plus 6 electrons. I got it all into one line. So the 6 electrons on both sides will cancel. The 7H plus is partially canceled with the 8H pluses, so you're left over with 1H plus. The 8 waters cancels with the 2 waters, so that you're left with 6 waters. Everything else remains the same. Now, because we're balancing in base, before I write down all the other stuff, I want this reaction to contain only hydroxides at the end. So I've got an H plus in there. For now, it's balanced in acid. So the way we balance in base is you take the side that has H plus and you add as many hydroxides as is necessary to balance it. So this conceptually turns into water. turns into an H2O. And if I add it to one side, I gotta add it to the other side. So I have to add an OH minus to the left side as well. So now I have an H2O on this side, you have 6 H2Os on that side, so that cancels again to give you 5 H2Os. Now we can rewrite the equation with everything correctly balanced. So the net equation is, and also show your states, nitrite anion aqueous plus 2 aluminum solid plus OH minus aqueous plus 5 H2O liquid yields ammonia and H3 aqueous plus 2 aluminum hydroxides with a -1, and that would be aqueous. Yeah, and that's it. That's the balanced equation. Have I copied it correctly? Yes, that is the correct answer. So here's what you can try for homework. This is part B. This is page 855B. I'll give you the question. I'll copy the question for you since you don't have the book with you. But it goes chromic hydroxide, solid, plus hypochlorite, aqueous, turns into chromate, aqueous, and chlorine gas. Chlorine is a gas. Okay? Balance that under basic conditions. That's your homework. Okay? You've got some other homework though. I'm going to give you some more as well. Yeah. So try that for homework, and then also watch parts 4, 5, and 6 of the electrochemistry playlist. Okay? And tomorrow I will show you how to draw a voltaic cell, and I'll give you the answer to this, and we'll do a couple other practice examples. Okay? So get to work, and we'll see you tomorrow.